Welcome to VW 4.7. Today we're going to be talking about more graphs. So for our first example, look at this. I'm giving you this graph f of x. So this is again a given graph, this shape. We'll do A in black. It says find f of 2x. So recall that if it's on the inside, that should affect the x. And what's going to happen is it's going to do x times the reciprocal, 1 over 2. And again, the reason for that is because if you imagine this graph, like you imagine this is you running a race, this 2 is going to make your graph go 2 times faster. So imagine that if you went 2 times faster, what's going to happen is instead of taking 4 seconds to do this route right here, if you're 2 times faster, you're going to go to 2 seconds. So that first point is going to be actually 2, 0. So that 4, 0 right here becomes 2, 0. 0, 0 will of course remain the same. And then 2, negative 2, instead of taking 2 seconds to get to this point, you're just going to take 1 second. So it's going to be 1, negative 2. So now we have this. So now look here. If you imagine this is you running, if it takes negative 4 seconds to get to this point, half that, it'll become negative 2. And then the final point is going to be negative 1, 4. And there's part A. For part B, we'll do that in blue. So same idea. You imagine that this is you running a race. If it takes you 4 seconds to get to this point, so imagine this is your time. Might help to think of it that way. It takes 4 seconds to get to this point in the race. If you're going half as fast, what happens is you're going slower, which means your time should increase. And it's going to be a factor of 2. So this is going to take all your x values and multiply them by 2. So instead of 4, 0, it's going to be 8, 0. 0, 0 is going to be the same. And this 2, negative 2 is going to be 4, negative 2. So notice how all we're doing is we're stretching the x values. Apply the same thing to the other side. Negative 8, negative 4, and then we're going to connect it. And there it is. So to summarize, I'll put that over here. Just remember our stretching rules. You have a times f of x versus f of a times x. This one is y times a, and the other one is x times the reciprocal of a. And again, for this one, it's counterintuitive because, again, you're thinking about it as if this were like a person running a race. This 2 will speed your graph up, meaning it actually compresses it by a factor of 2. This will speed your graph down, or it'll speed you, or lower your speed, so it'll elongate the graph by a factor of 2. And that's what you're seeing here. For C and D, this first one says absolute value of f of x, which means absolute value of y. So what you're going to do is you're going to make all y values positive. So this first part should still be there because that's all positive. And I'll do this one in red. So all the places where y is already positive, let's leave that alone. Y is negative here, so let's just make them positive. And here's our graph. Done. Now this next part is where it gets a little bit weird. It says f of the absolute value of x. So to do that, let's think about if x is positive. So if x is greater than 0, because of the absolute value, nothing should happen. So if you look at this part right here, that part of the graph should still be there, like that. So nothing really happens with that part of the graph. The issue comes on the negative side, like what's going to happen there. So to figure that out, I'm going to make a little chart or a diagram here. We're going to plug in -1, and we're going to wonder what happens. So -1, that's f of the absolute value of -1, but the absolute value of -1 is 1. So notice how I'm plugging in -1, it goes into our function, but the absolute value converts that to a +1. And to find f of 1, you have to look at what we already did. F of 1 is right here. That would be -1, which means your first point is -1, -1. So I put that there. We're going to repeat that process to find the other points. So get rid of that. Let's plug in -2. You plug in -2 there. The absolute value of -2 is 2, and f of 2 is right here. That's -2. So our point is -2, -2. And now you should be able to see what's happening. The graph is simply reflecting the positive part onto the negative part. And what's really weird is this part, this like parabola shape, is just gone. So to summarize, what this is doing is it overwrites the left, or the negative side, with the right, or the positive side. Now we go to the final part. It says assume AB is a point on the graph, which is the corresponding point on the graph for each of the following functions. So for these, just think about what's happening. Negative inside would mean reflect over the y-axis. And to do these, just imagine your point AB in quadrant 1. That's going to be the easiest to think about. If you reflect over y-axis, that'll be right here. So that would be -a comma b. This would be y times 2. So that would be a comma 2b. Just imagine that like up here. It's times y by 2. This one is right 3 units. So maybe I'll do that in blue for you. So move that right 3 units. That's actually going to add 3 to A. And this one is clearly going to be down 3. So let's say that's over here. Same x value, but b gets subtracted by 3. So the main thing for these is just write out what's actually happening. So see, that's what I'm doing here. And then it helps you see what happens to the generic coordinate a comma b. And that's it.